is a simple harmonic motion question. We've got a body that moves with simple harmonic motion about some mean position O. It has an amplitude of 2 meters. So what that means is that the maximum displacement, if you like, or maximum distance from the origin is 2 meters. Has a period of pi on 2. Now that's pi on 2 seconds. Period is really just how long it takes for the particle to do one complete cycle. So, you know, if it was starting at the origin, one complete cycle would be out to its extreme position out here, all the way back through here, and then back to the origin over here. That would take pi on 2 seconds. Some other information is we've got at time is equal to 0, displacement is equal to √3 meters. Now, quite often with these situations, at time equals 0, the displacement is 0, so it actually starts at the origin. In this case here, we've got the particle starting at x is equal to √3 meters. Now, if displacement is 2 meters here, √3 is going to be, you know, out over here somewhere. So a particle is starting out over here somewhere. Just call that P. And it's moving with some velocity at this point. Also, it does tell you that initial velocity is positive. So initial velocity positive, going in the positive direction. There's our velocity. Remembering with your simple harmonic motion as well, that wherever the displacement is, if that's a positive displacement, the acceleration is always in the opposite direction to displacement. So, you know, at this point here, acceleration is back towards the origin. There's sort of an acceleration pulling that point back towards the origin. Okay, so what we want to do is find an expression for the displacement x. Now, because it's simple harmonic motion, we know that it's going to be of this form here. X is equal to a sine kt plus alpha. Now, if the initial position of the particle at t is equal to 0 was 0, we wouldn't have to worry about this alpha value. Alpha is kind of like a phase shift. So, for example, x is equal to a sine kt would be for a particle which is starting at the origin. X is equal to a sine kt plus pi on 2 would be for a particle starting at this extreme position here. And that's really the same thing as a cos kt. Just put a room there. A cos kt. Okay, but in this case here we do have some alpha value because the particle is starting out over here. What we do know, however, is that because the amplitude is 2 meters, this a value here will be 2, so we can write that down. X is equal to 2 sine kt plus alpha. We also have the period. Now, with the period, we know that the period, which we often denote t, is equal to 2 pi over k. So there's a relationship here between the period t in seconds and this k value in our equation. So because the period is actually equal to pi on 2 seconds, we can say that pi on 2 is equal to 2 pi on k, and just solve that little equation. Cross multiplying there, we'll get k is equal to 4 pi over pi. Pi's cancel. We have k equals 4. So at this stage here we get down to our displacement equation being 2 sine k value is equal to 4t plus alpha. Okay, so now to get our equation, all we need to do is just find this alpha value. So we can just do a simple substitution here. So going back to what we had up here, which was at t is equal to 0, displacement is equal to √3. We can just substitute that in. So at t is equal to 0, we've got a displacement of √3. So we have √3 is equal to 2 sine. Now 4 times 0 here will be 0, 0 plus alpha. Or if you like there, we have √3 over 2 is equal to, whoops, that means the 2's gone there. √3 is equal to sine alpha. Now solving that, we've got one of our exact values here, √3 on 2. So that'll generate an answer here of alpha is equal to pi on 3. Now working in radians here, we're in degrees, that would be 60 degrees. But we must consider also our unit circle. So with our unit circle, we have our angle here at pi on 3, which is somewhere up over here. But because we're dealing with sine here, and sine is positive in this quadrant as well, so they're both, all trig ratios are positive here, sine in this one, tan and cos. So another possible answer for alpha would be 180 or pi radians take away pi on 3, which gives us 2 pi on 3 as a second possible answer. Okay, so at this stage here we've now got two possible solutions for x. We've got x is equal to 2 sine 4t plus pi on 3, or x is equal to 2 sine 4t plus 2 pi on 3. And to work out which one we're going to use, is we go back to the final bit of information we had in our question here, which is that the initial velocity is positive. Okay, so I mean, what we could do here if we wanted to, there's a couple of ways of working out which one to use. We could actually differentiate these expressions and get expressions for velocity. So for the first one here, differentiate that, I'll get velocity is equal to multiplied by the 4 here, so we'll get 8 cos 4t plus pi on 3. And differentiating the second one, we get velocity is equal to 8 cos 4t plus 2 pi on 3. So we want our initial velocity to be positive. So if we inspect these ones here, if initial velocity, in other words, when t is equal to 0, this velocity equation here will be 8 cos pi on 3. Initially, this velocity here will be 8 cos 2 pi on 3. And then what we can see there from that is that, let's just write that out here. We've got V0 is equal to 8 cos pi on 3. In this case, V0 is equal to 8 cos 2 pi on 3. Now, cos pi on 3, going back to our unit circle here, cos pi on 3 would give a positive result. So this is a positive velocity, whereas the second equation here generates a velocity, initial velocity with 2 pi on 3 in this quadrant here, and this quadrant cos is negative, so this will actually give a negative velocity. So therefore, the equation that we're after, so for positive velocity, for positive initial velocity, our equation will be x is equal to 2 sine 4t plus pi on 3. Now, we could have figured that out without doing our differentiation here. We could have just gone back and had a look at our actual particle and how it's moving. What we imagine here is if that initial velocity is at this point sort of on the way out to the extreme position, it's before we get to that phase shift of pi on 2. So with the plus pi on 2, that's when we're at the starting at the extreme position. So because pi on 3 is before that pi on 2 value, the particle is still heading out that way and the velocity is positive. If that angle 2 pi was 2 pi on 3, it means that it's gone out to pi on 2 and it's coming back towards 2 pi on 3. The particle's back here and the velocity would be in this direction, which would be negative. So really just by inspecting what the particle's doing, we could have identified that out of these two equations here, it's this one here that will generate that initial positive velocity rather than that one. Okay, I was going to do a couple of extra parts, just working out a maximum speed and acceleration, but I'll leave that for another video maybe.